Hi everyone. It's very nice to be here today, and I will tell you something about how we in the Netherlands are upscaling the building with bio-based materials. But first of all, I want to focus on why are we building with bio-based material? Why do we want this? That's because we have very much societal issues, and we can influence that with bio-based construction. We can fighting climate change by CO2 reduction in the construction and agriculture sector, because we are building lighter with bio-based materials. We can also store the CO2. But we are also working on circular economy by the reduction of non-bio-based materials. Nitrogen reduction is also an important issue. We can use durable business models. We can make regional value change, so the transportation is less, etc. That's all good for reducing the nitrogen reduction. And when we use the, thank you, when we are also using the farming industry as the producers of building products, then we can also recover biodiversity and water equality. We can change from cattle to crop growth. We can make an impact on the response to wet and dry grounds, which is very important in the Netherlands because we have all kinds of layers in the Netherlands that when you reduce the water, the groundwater average, then there's a lot of CO2 coming out. And with these crops like reed or whatever, you can raise this groundwater. And also spatial quality. So there's a lot of aspects that are, that we can contribute to in societal issues with bio-based construction. But that's as a starter. I was already introduced, but I'll introduce myself as well a little bit. I was an architect. I am an architect since 1997. I worked as an employed architect with several architecting organizations, and I made a lot of social housing. And apart from that, I also did something with utilitarian projects, mostly hospitals. I like that also very much. So I started for myself in 2007. I thought I can do that on my own. But then in 2008, you can remember there was a big crisis, financial crisis. And in the Netherlands, it costed 30% of all the architecture offices were gone. And I was one of them. But I lasted until 2010. And then I was employed at SBR, which is the Foundation for Building Research. And since 2017, I am self-employed also in knowledge dissemination and knowledge development for the building sector. And I'm teaching and consulting on building technology, building physics, and building regulations. And I do that for different organizations like ISO, which is a foundation for building systems and constructions, and they also have different publications on building in general and also validated details. I do that for BRIS now, all different kinds of organizations, the Ministry of Housing. I lecture at the Brandpreventie Academy, and I've several certifying institutions and more. And last, I'm secretary of an advisory committee on building regulations, and we call it equally safe measures. So you can deflect from what's in the regulations, and you can do it in another way, as long as it is equally safe or good. And since 2024, I work for Building Balance. Now we'll focus on the Building Balance part, where everything comes together. First, the goals and the approach. The main goals are managing the reduction on the CO2 imprint in the Dutch building sector. And we've seen how much that is in the slide Anna showed you. So reduction of fossil materials, stimulating building with bio-based and preferably Dutch agro-based materials. So we specifically try to use agro-based, so what grows on the fields, materials. And we are capturing CO2 in buildings by bio-based materials. And I use the word bio-based, but I have noticed that you use the term biogenic. Yeah, in my opinion, it's the same. I'm used to the term bio-based, so if you don't mind, I still use this term. And what is it? Well, it's use of wood products, preferably European, use of a lot of residual products. So those are products that are also in other chains in the industry, for example, like the car industry, etc. And residues of that we can use in the building sector. Also for cattle, the straw we put now on the floor, but we can also use it in a house, and there it remains. And use of specially grown crops like flax and hemp and miscanthus, which is elephant grass, and other ones. Now all these goals and the whole approach is put into the national approach to bio-based construction. This was at the end of 2023. This was the start of Building Balance. We had an initiative for upscaling. That was the main goal, and it was supported financially, mostly by 4 different ministries. So the Ministry of Domestic Affairs, the Ministry of Economic Affairs and Climate Policy, the Ministry of Agriculture, Nature and Food Quality, and the Ministry of Infrastructure and Water Management. All these 4 ministries thought it was important to reduce our CO2 emission in the building industry. And therefore, Building Balance was founded, and it will also disappear again in 2030. And there's a lot of money involved. You see here the numbers. So that means that it's not all for Building Balance, but Building Balance can use a lot of this money. And so we can do a lot of research, and we can really do things to scale up the bio-based building. The total budget for transition of bio-based value chains up to 2030 is 200 million euros, which I calculated is about 1,500 million Danish crowns. So that's a lot of money. How do we do that? We do that from van land tot pand. I translated that, it must be fra land til huis, or something like that. And we do that by developing and upscaling different business models. Business models in agriculture, so that's the agro-based side. In the industry, where we can process the agricultural products. But also, if it's not agricultural, but it's from wood, we can also make this industry scale up. And in the building sector. And we are also developing and upscaling regional value chains. And on the one side, we have agricultural production. On the other side, we have construction and infrastructure, and we want that to bring that together. So we do that by processing all the agricultural products, make it into products and materials, and then use that for construction and infrastructure. And we try to do that all within a region. So the transporting is not so much. And what we see is also that it's nice if in your region everybody works together, has the same ambition to do it all bio-based. So we see that this works very well. These people are inspiring each other in regional value chains. So the agricultural production, we are stimulating as building balance the agricultural production of crops, mostly fiber crops we use for insulation. We are stimulating factories, new factories, existing factories, we do it all for processing these fiber insulations and also for processing different kinds of fiber boards. We are stimulating product development for building and infrastructure, and we are stimulating different parties for supply and demand. So we bring together the supply and the demand. You will ask, how will you do that? Well, we started with letters of intent and agreements. So we talk with people, inspire them, and then we let them sign a contract, an agreement that they will, in the coming years, a lot of their production, they will do that on bio-based basis. We do that with farmers, with manufacturing companies, and also with architects, contractors, housing corporations, and property developers. They all have a certificate, and I've seen several architects, and on the wall near the entrance, there's a big certificate, we are partner of Building Balance. So this works. So all this together is what Building Balance does. So it's the whole chain. Now, and in this letters of intent, briefly, it says that by 2030, 30% of all your turnover or assignments will consist of 30% of bio-based products. And a product is considered bio-based if it consists of 30 mass% of renewable materials. If there's also been a discussion, should it not be volume percentage, but eventually it is mass percentage. And it's lightweight, so it's really difficult sometimes to reach this 30% because stone is a lot heavier than bio-based materials. So 30% is really more than it seems. Now, what do I do in this endeavor? I do a lot of things, and it's mainly focused on building the trust in the construction sector. So everybody has to trust that building with bio-based materials is a good thing, and it's not dangerous, and it's durable, sustainable, etc. But there's a lot of resistance. So, for example, sound insulation, we research and test different walls that we never used in the Netherlands before. So we use these cavity walls between two houses, but never with blown in vegetable fibers. It's 120 wide here, and we are used in the Netherlands to make everything as small as possible. So it's mostly 90, and here it's 120. And we have here a board on the cavity side. Yeah, in the Netherlands we never use boards on the cavity side because that's not good for the sound resistance. But we did it, and we tested it, and it works if it's a flexible board. Now, we researched, we tested a lot of these walls, but what we also did is testing different materials. And we test them on certain properties for the sound insulation, like airflow resistance, the rigidness, so how stiff is it, and we did it on different kinds of materials. And with that properties, we can make we can design other structures that are not tested. So we use the test results of the tested walls in the software. We can use the other materials, and then we can take a good guess what will be the sound insulation of that wall. So then with some tests and with this small test, we can reach the sound insulation of a lot of different constructions. That was sound. Moist, oh, sorry. Moist and mold. We are also researching and testing on that, and we are doing the correlation. We are determining the correlation between the relative humidity and the equilibrium moisture content. So you can understand that when you have a vegetable fiber, that it's getting wet once the surrounding is wetter and wetter. So when it's 80% relative humidity, it will be more wet. But how wet can it be before it will grow mold on it? We don't know. So we're testing that. So we're testing what's the correlation between, you see that in the diagram, the correlation between relative humidity and the equilibrium moisture content. And we think that should be between the 15 and the 20% moisture in vegetable fibers. And we use at what equilibrium moisture content will be used to grow mold. And when the results are good, as I think they will be, but we don't know yet, then it's even more safer to use it without the risk of growing mold on it. We also the resistance of decay, how it's the material just disappears in time. Then we are also calculating on that, so that's other kinds of research, and we do that for all kinds of constructions we make. Also, when I make details, I use always calculations on the moist. So we calculate statically with Glaser. I believe you all know it, I hope. And you can also use a software package we use a lot. It's called biobased. It's from Uweert in Germany. I don't know if you know that. And it works very good, but it only works when there's no internal condensation in the construction. But when there will be internal condensation, we think it's not so bad when it doesn't last too long, because it won't decay and there won't be mold growth. But we don't really know. And how long can it be wet before it dries? Now, then we have to go to a dynamic calculation, and we do that with WUFI Pro. WUFI is a software package of Fraunhofer Institute in Germany, and it's really the top of the bill package. And then you do it dynamically, so you take, in our case, the Dutch climate over 5 to 10 years, and you calculate on which climate, on what weather in those past 10 years, for example, on which weather there will be internal condensation, and when it can dry out, and how long this wetting takes. Now that's on moist and mold. And then fire safety. We're also doing a lot of research. We have done a lot of research. This is really finished for a great deal. Research and testing of fire safety of walls. I saw that you in Denmark do large-scale tests. This is the largest we can do here. So we are now upscaling in the Netherlands. We have 2 fire laboratories in the Netherlands. We are trying to get it bigger, but it's not so easy because the roof is too low. Yeah, I can't help it. So we're researching all kinds of walls. This is an example of a load-bearing wall, and you see it in the moment that it fails. And we are also interpreting and interpolating the test results of those fire safety tests. And we do that with the help of some new documents, which are very interesting, namely the new design Eurocode 5. So that's the Eurocode on wood structures. And they have new definitions in it. And it's like the charring time and the failure time of the fire protection system. The charring time is the time that a vegetable fiber or an organic material, which is behind a fireboard, like a gypsum board, for example, or whatever, and the time after the ignition of the fire, when will it start to char? And when you know that for different materials behind a protection layer, then you can switch all these materials into different constructions, and you can take a good guess how fire resistant that will be. There's also the failure time of the protection layer, so for the gypsum board, for example. And we also have the protection level classification. That's also new. And here we have done tests on that. And the main thing of that is that the vegetable fiber insulation is in the same class, according to this new Eurocode, as glass wool. And we build a lot with glass wool. So how is this possible? Well, glass melts at 700 degrees. A real fire, a developed fire, is at least 800 degrees. So the glass wool will be gone, as will the vegetable fiber. But we have a lot of constructions with glass wool, so that's something we can relate to. So we use this PL2 test to also to switch between glass wool and vegetable fibers. And we also have help of the newly introduced fire protection ability. I don't know if you have heard of that. It's all very technical, of course, but I think it's very important, because if you are going to use bio-based materials, then you have to know more and more of these properties that are valid. Because when you build with stone, yeah, nothing happens. When you build with stone wool, it's no problem. But now we build with materials that can burn. So you have to know more about these definitions. And the K2 factor is the fire protection ability. You use that in the KT 10, 30, and 60. That means that this material, like a board, will remain cold on the not heated side for 10, 30, or 60 minutes. And at 300 degrees, and that is a temperature that is nearly the ignition temperature of a vegetable fiber. So with that, with all the tests and with these new definitions, we made a construction overview with 650 construction types. It was a real hell of a job. And in this construction overview, it's all free. You can find it on nkbb.org. And then you can find this construction overview. You find the results of the tests itself, and also the results of, I call it the recent equivalence of different variants based on the interpolated test results and on the classification according to the Eurocode with these definitions. Now, it's too difficult to do this now in half an hour, but it's really mind-blowing. We do also various other research. Just in short, we are measuring all kinds of lambda values for the insulation of vegetable fibers, because we had to use all, we call it forfaitaire values, and they were not good. So we tried to certify all different kinds of vegetable fibers and their lambda values. We also did research on phase shift. Phase shift means that when the sun is shining and it's getting hot, then inside it's still cool, but there's a, it takes some time before it's hot inside. Now, you can put hours on that, how much time it takes. Well, with stone, it's heavy, it takes a lot of time, and with light structures like bio-based materials, it's not that much as with stone. But it has an influence, a positive influence on how much energy you use. And that's now from end of May, it's in the Dutch building regulations that the phased shift, based on the research we did, is now also in the building regulations. So we can profit now from the phase shift in our energy calculations. We also did research for plague animals in bio-based buildings. Yes, and the conclusion was that there's no difference between a building with glass wool or a building with bio-based buildings, because in glass wool there's no nutrition in it, but in bio-based buildings there's also no nutrition in the bio-based fiber, so there's no difference. And we're also developing and upgrading several standards, several new standards for the fire safety of wooden high-rise buildings, for bio-based building in general. And we're also upgrading different standards, so like moist in buildings, and upgrade the phase shift I mentioned, and also for certifying lambda values. And even more, but this is a nice overview. Then we also developing validated reference construction details on newly built family houses. And here you see that for newly built family houses, the first project we did was in collaboration with the Dutch Flemish Foundation for Building with Straw, and this is an example of that one. We are now busy with the, let's say, the threshold energy that we need to get according to Dutch building regulations. Then we are also doing this for retrofit and renovation. We are also developing construction details. For example, for the thermal insulation of slopes, of sloped roofs. And this is from the inward out. So you see the Dutch sloping roof, which is not colored, and then the colored part is newly from the inside. And we also do that from the outside. And from the outside, we do that with prefab elements we put on top of the existing roof. Then first we remove the tiles and then put the prefab element on top of that. This is when one home is insulated and the other is not. And we are also developing details on insulating walls from the inside of existing buildings, here you see, and also of ground floors, which are not insulated mostly, and we want to insulate it, in this case, detail from inside. But for a detail is a connection between different construction elements. So what we do is we define a facade construction and we define a ground floor construction, and then we make the connection. So in this definition of the construction elements, on the right you see the ground floor. We define the RC value. We also define the sound resistance, now not for the ground floor but for the wall, and also the sound performances between rooms, like the DNT, AK, etc. And also the fire resistance. And then when we make this connection, when we make a detail, we want that you can use this detail in your own project details, and that's a difficult thing. So what we do is we make all the physical properties of a detail visually visual. So here you see visually made the thermal insulation and the boundaries of the thermal insulation of a rooftop. And that is important because in between of these rooftops you have the lineal thermal bridge, and we also have to calculate that for the newly built building. So that's the energy loss through a connection. We also do that for the water tightness. So how does this water tightness, how does it work? And when you have your own project detail, then you can look how this is built up. And if you build this up in your own project detail, then it will work the same way. Also for vapor resistance, air tightness, sound insulation, and for fire resistance. Just for fire resistance, all the trajectories of the fire spread through the connection are here worked out and are evaluated to see that the fire will not spread within 60 minutes towards the neighbor. Now, last things, the research, the results we had on the upscaling of bio-based building. In 2025, you see there's a goal with a red arrow that's really low. You see that the goals are the yellow stripes. The goals towards 2030 are that in 2030 we need to have 50,000 houses with bio-based materials. But you see that now in 2025 we did a lot. We did 5,300. Oh, time's up, huh? Oh, yeah, okay. We did 5,317. Oh, I think there's no power in it, so the power is out. Oh, okay. Okay. Well, I'll do this again. Yeah. I was here. The goal, so we realized a lot in 2025, and you see all the green, all the green things. It's a lot because we are now already working on the design of houses in the coming years. So in the development, and we already know that we are going in that direction. So you see that with newly built buildings, we are reaching our goals more than we ever imagined. And in the retrofit and renovation, it's also going well. As you see in 2025, we realized more than we agreed upon. But you also see that we have to do a lot of work with that. And then when you look at the results, then you see that there's a shift from activation, which was the start in 2023, to realization, so actual building in 2025. And in the first half of 2026, 350 mostly large companies and organizations have signed a letter of intent. And you see that 50% of all projects are pilot projects, which means they are done by parties that have never used bio-based building before. And 50% are follow-up projects. So that's also going very well. And we have a decrease in resistance, which is positive, against bio-based building. We see that with municipalities and fire departments, etc. And that's all also based on the research, etc. and the whole thing we are doing. We see an increase in regional value chains, and we see that infrastructural projects, which we also do, I didn't discuss this now, but it's also upscaling very fast. The problems we still have is that upscaling is always project-based, and it's not systematically in the companies and the standards. And the agro crop growing is upscaling. That's going well, but it's not always used in the construction sector because the chain is not reacting as it should yet. And the processing industry won't scale up yet. So that's it. Thank you for your attention.